Good morning, respected sir. Myself, I am Tirmalesh from Department of Civil Engineering. Today I am going to explain about CAA-2 in strength of materials. Here is my topic. My topic name is the assumptions in the theory of pure bending. Assumptions in pure bending. Let us know about introduction to pure bending. Pure bending refers to a bending condition where the internal bending moment is constant along the length of the beam. It assumes the beam is subjected to moments without any shear force. It is subjected to the moments without any shear forces. And understanding assumptions helps in simplifying analysis and designing efficient structures. And assumptions of plane sections. The cross sections of the beam remain plane and perpendicular to the neutral axis after bending. This implies no warping or twisting of the cross section occurs during bending. It simplifies the stresses analysis by assuming the linear strain distribution across the section. Homogeneity of material. The material of the beam is assumed to be homogeneous, meaning it has uniform properties throughout. It is meaning properties throughout. This ensures consistent stresses and strains responses across the entire cross section. Homogeneity is essential for accurate application of bending theories. And next one is isotropy of material. This material is assumed to be isotropic, having identical properties in all directions. Isotropy allows the use of simple elastic formulas without considering directional differences. This assumption simplifies the calculation of stresses and strains under bending. Here is a diagram for isotropic material. A point A a point A property of material should be small in all directions that are 1, 2 and 3, but it might be possible that property of point A and B may be different. Point A and B may be different are shown in the isotropic material of the figure. And next one is elastic behavior of the material. The material is assumed to be behave elastically obeying Hooke's law within the elastic limit. The material is assumed to behave elastically obeying Hooke's law within the elastic limit. This means stress is directly proportional to strain under and deformation of recoverable. Elastic assumptions are crucial for applying classical bending theory accurately. This is one of the example for behavior of elastic material. And the next one is neglect of shear effects. Pure bending assumes shear forces are negligible compared to while bending moments. This means the primary stresses are normal stresses, not shear stresses. The assumption implies analysis, but it is valid only for cylinder beams under the bending. Small deformations. Deformations are assumed to be small enough that linear elastically applies. Large deformations which could alter the geometry significantly are neglected. This assumption ensures the validity of linear bending equation and stress distributions also. Neutral axis assumption. In pure bending theory, neutral axis plays an important role. The neutral axis is processed through the centroid of the cross section in pure bending. It passes through the centroid of the cross section in pure bending. This axis experiences zero longitudinal strain during bending. The position of the neutral axis is crucial for determining stresses distribution. Shortly, neutral axis is called an imaginary line in the pure bending. Symmetry of cross section. Many bending assumptions rely on the cross section being symmetric about the neutral axis. Symmetry simplifies the calculation of moment of inertia and stresses distributions. For a symmetric section, additional considerations are necessary, but basic assumptions often still hold. Summary and limitations. Assumptions in pure bending facilitate simplified analysis and design. They are valid primarily for cylinder, homogeneous, and elastic beams under small deflections. Recognizing the limitations ensures appropriate application and accuracy of bending theory. This is all about pure bending theory, assumptions in pure bending theory. Thank you.